Hello, good evening, dear students. So, this is Sohida Begum. Today, we're going to explain our next topic, balanced chemical equations. So, this is very much important that how you can balance a chemical equation. So, here we will learn how we can balance a chemical equation. Let's see what things are given. If you go word by word, you can easily understand. So here given, recall the law of conservation of mass that you studied in class 9. So mass can neither be created nor destroyed. This is the law of conservation. We cannot create, we cannot destroy any mass. Okay, that is the total mass of the element present in the product of a chemical reaction has to be equal to the mass of the element present in the reactant. Means after reaction and before reaction, the mass of the reactant or product will be same. This is the law of conservation of mass. Sometimes question may come why we have to balance chemical equation. So this is the result, because we have to obey the law of conservation of mass. Due to this, we have to balance chemical equation. So in other words, the number of atom in of each element remains the same. So same mass, that means atom will be same number of atom before and after a chemical reaction. Hence we need to balance a skeletal chemical equation. Before we are getting one in our last class we discussed what is skeletal. So is the chemical equation 1.2, before we are getting 1.2, this one is skeletal this one balanced or not unbalanced. So here see one magnesium, so here also one magnesium, two oxygen, but in product one oxygen, so it is not balanced. Okay, so how we can balance? Let's see. Let us learn about the balancing a chemical equation step by step. So the word equation for activity, where one word equation given, zinc plus sulfuric acid, and after that product we get zinc sulfate plus hydrogen. So they are writing the word equation also in chemical using chemical formula, zinc Zn plus H2SO4, that means sulfuric acid. Then we are getting zinc sulfate and plus hydrogen. This is the skeletal chemical equation. Now see number of atom. Before reaction zinc 1, after reaction zinc 1. Number atomicity, you can say on how many zinc is there. Then you say hydrogen, before reaction hydrogen 2, after also 2. Like this sulfur and oxygen same. That means number of atom in the reactant and number of atom in the product is same. So number of atom in a reactant and number of atom in product same. So it is a balanced chemical equation. So we no need to balance again. Let's see next one. This one, Fe iron plus H2O water, then Fe3O4 and plus H2. This is getting. So here see in product in reactant Fe1 and in product means in a product 3. Like hydrogen here 2, again 2 same. Oxygen in reactant 1 and in product 4. So here all are unbalanced, so we have to balance. Now how we will balance? So step 1, to balance a chemical equation, first draw boxes around each formula. Look how they are making boxes. Do not sense anything inside the box, everything will be same. Now step 2, list the number of atom of different element present in the unbalanced equation. Now see iron in reactant 1, in product 3, hydrogen 2, 2 same, oxygen 1 and 4. Okay, now it is step 3 now. Step 1 you have to make box, step 2 you have to write the number of atoms in product and reactant, and now step 3, it is often convenient to start balancing with the compound that contain the maximum number of atom. Here you see where is the maximum number of atom? Oxygen, that is 4. So it may be a reactant or a product. No need to confuse. So in that compound, select the element which has maximum number of atom. Using this criteria, we select. So here we see that which product is more? 4, oxygen. So where? In product part. No, that means which one? Fe3O4, that one. Using this criteria, we select Fe3O4 and the element oxygen in it. So in Fe3O4, oxygen atom, that is 4. So we have to balance now. So initial it was 1, and in product, initial it was 1 in H2O. O is where? In H2O. And next in product, O is where? In Fe3O4. So we have to multiply 4. So it will balance, that means it will be same. So 1 into 4 here, that means in H2O it will be 4, and here also no need to change anything here, 4 only. So now our reaction will become like this. Iron 4H2O, because we have to multiply it in Fe3O4 and H2 like this. Now again you see where means unbalance is there. Now atom of hydrogen, in initial it is 8, 4H2O, that means 4 into 2, 8, and in reactant part it is, and in product part hydrogen, no, in product part it is 2. So we have to balance. So 8 and 4, so we have to multiply 4. So here we are multiplying it by 4. So it become iron plus 4H2O Fe3O4 like this. So again you see where there is unbalance. Iron, now iron is 1 in reactant, and in product it is 3. So again we have to multiply 3. Where? In reactant part. So 3 iron, now you see everything. 3 iron, here also 3, 8 hydrogen, oxygen 4, everything is balanced. So like this we can balance a chemical reaction. When you do it means many times, you will be expert. It is no need to make then boxes, all this. For first time you have to make boxes, and you have to do like step by step. So next is for step 7, writing symbol of physical state. So carefully examine the above balance equation. Does this equation tell us anything about the physical state of each reactant? And so the gases, liquid, aqueous and solid state of reactant and product are represented by the notation. If it is in gaseous state, it will be, okay, sorry, so no information has been given in this equation about their physical state. So in this equation there is no not physical state is not given. No information is given about it is in gases or it is in liquid or where. But how we can give? So to make a chemical more informative, if you want to know more information about the chemical reaction, we can use the physical state. By using it is in gases, you will write Z. If it is in liquid, you will write L. If it is aqueous, then AQ. And if it is solid, then S. The word, now you are getting aqueous is new thing. What is aqueous, liquid or what? So the word aqueous is written if the reactant or product is present as a solution in water. If the product is a solution of water, then it is written as aqueous. Now look, iron is solid given, 4H2O, water is gases. Here gases form it is written, that means steam. Then again Fe3O4 is solid, then H2 is hydrogen gas, that means. Note that the simple Z is used with H2O to indicate that is this reaction water is used in the form of steam, not used in is the form of water. If it is in the form of water, then it will L. So some usually physical states are not included in a chemical equation unless it is necessary to specify them. If it is not necessary, we are not using these physical states. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. So sometimes like this written, like here carbon monoxide is 2, here above 340 atmospheric pressure. Then here also written sunlight, in presence of sunlight and chlorine. This is the reaction of photosynthesis, right? Carbon dioxide and water. So using this step, you can balance a chemical equation. 1.2 given in the text earlier. So we can do that one also, 1.2 equation also. So this is the whole process by which we can write a chemical reaction, we can balance a chemical equation, and how to balance. This is the process. Okay, in next class I will explain these questions, and if I possible I will give some another example also that you can do. So for today, thank you. If you have any doubt, any problem, you can comment, you can write on the comment section. Thank you.